As you can see, the title of my talk is somewhat different from what we have been hearing so far for this session. So this is rather experimental and rather in laboratory scale. The background about this research was, we all know we have some problem in producing biodiesel, especially from food crops. So today's, say, keynote speaker said. So the idea we kind of asked, because all the wastewater, including domestic wastewater or industrial wastewater, in this case, food industry wastewater, like brewery wastewater, we have to treat. So if there is any way while we're treating wastewater, at the same time to produce biodiesel, would be a whole lot better idea than producing biodiesel from food crops or even non-food crops. So that is the background about this research. And why then, so we used, so this is biological diesel production. So we have to use some kind of microorganisms. In this case, we decided to use oleaginous yeast, Rhodosporidium toruloides. And we also tested with real wastewater. But this one, we used mixed wastewater of distillery, rice wine wastewater, together with domestic wastewater, because especially in developing countries like China, to carry wastewater, all kinds of wastewater, domestic, industrial, agricultural, livestock, most areas we have so-called combined sewer. Combined sewer means industrial wastewater mixed with domestic wastewater and then going to wastewater treatment plant and then will be treated. So that is why in this case we used mixed wastewater. I skip about shortage of fossil fuel. We all know we have energy crisis, high energy price. At the same time, we worry about environmental security. So biodiesel as a renewable and environmental friendly energy has promising future. So large amount of food industry wastewater generated worldwide. And in case of China, China means mainland China. They expected by 2012 almost like 210 million tons of wastewater generated from brewery industries, including rice wine industries. And food industry wastewater is very difficult to treat. It doesn't matter you use chemical treatment, physical chemical treatment, or biological treatment, because it contains high chemical oxygen demand. So this is for organic contaminants, and together with high total nitrogen and total, how you go back? Go back. Okay. Thank you. It also contains, say, high total nitrogen and total phosphorus. And these nitrogen and phosphorus as nutrients can lead to eutrophication and algal bloom. So rather cost-effective treatment process is required. And I think this already mentioned in biodiesel industry. So-called first-generation biodiesel mainly derived from food crops, like rapeseed or soybean, sugarcane. And then second-generation biodiesel produced using oils from non-food crops, non-edible plants. So it's still lots of controversy going on between, say, crops for biodiesel production and crops for food supply. And more cropland needed. meaning less forest, also meaning more greenhouse gas production. So third generation biodiesel produced from so-called oleaginous microorganisms like microalgae or yeast. But still, currently existing processes require, even though using oleaginous microorganisms, still requiring using fertilizer or external carbon source for their growth. So production cost is still high. So further summarized here, see? For this research, to get high density culture, yeast culture, using real wastewater, to get high cell density seed culture of yeast strain, we need to use seed medium. And in this case, we use YPD medium. It's short for yeast extract and peptone and glucose or dextrose. So for this specific research, we wanted to know, while maintaining same efficiency, biolipid or biodiesel production, we wanted to know whether any way to save this initial growth medium. So we wanted to reuse, actually. So objectives were first to explore potential of reusing spent seed culture medium because this costs lots of money. And then to assess biolipid productivity together with removal efficiencies for organics and nutrient contaminants from real wastewater. Oops. Cut it off. So this is overall workflow. So this, oops. So as you can see in blue, okay, YPD medium. Other flow pretty much same. We grow yeast in growth medium, YPD medium. And then we treat real wastewater. We check biolipid productivity together with wastewater treatment. And then this initial growth medium reused once, reused twice, and then we checked same biolipid productivity together with removal efficiencies for organic and inorganic contaminants. So we sampled real rice wine distillery wastewater from mainland and domestic wastewater from Macau. And then this table further shows the composition. As you can see here, distillery wastewater with very high soluble chemical oxygen demand for organics and total nitrogen and total phosphorus and ammonia nitrogen. And then we mixed 1-to-1. And I already mentioned seed culture medium. And the organism, oleaginous microorganism we used was Rhodosporidium toruloide. So this is cultivation method, I skip. And yeah, again, this one. So after we grew the seed culture, we inoculated in real, non-sterile, mixed wastewater at fixed cell density here. And then we checked lipid productivity together with, say, treatment efficiency for wastewater. For some analytical method, we used acid hit method for lipid yield and the Hack method to check wastewater treatment. So this table shows results for cell yield from fresh medium and second time used medium, third time used medium. So this is kind of biomass formation. And then in terms of removal of chemical oxygen demand, you can see starting from around 29,000 milligram per liter after 5 days, as you can see from fresh medium, second time used medium with some nutrient supplementation, and third time used medium with nutrient supplementation. As you can see, in terms of COD removal, not that much difference between fresh and second reused medium. In terms of total nitrogen, total phosphorus, again, after 5 days, starting from these values after 5 days. Actually, in terms of total nitrogen, third time used medium even, say, removed more. Total phosphorus, pretty much same. In bar graph, further summarized in terms of biomass, lipid yield, lipid content. So this further summarize it's the approximation of cost when fresh medium was used and then second time used medium was used. These are all market price to produce a certain amount of yeast cells in fixed amount of gross medium. So as you can see, this column, total cost of materials for medium in US dollars, about 390 versus 280. Anyway, as a conclusion, by the way, I like to mention one more thing here. Even though for this talk, I'm focusing on reducing cost for this, say to use growth medium for this oleaginous yeast strain. Currently, we're also working on to further cut down the cost, production cost, again, with same efficiency in terms of biolipid productivity, converted to biodiesel. Currently, we're working on the last step, actually. Once lipid produced, accumulated on oleaginous organisms, it should be converted into fatty acid methyl ethers. It's precursor of diesel. And in that process, we call transesterification. We can use physical-chemical transesterification or microwave-assisted so-called direct transesterification process. So to further reduce cost, we're working on this one. So we compare both processes. So spent yeast growth medium with high cell density successfully reused for the second time. And yeast cells produced from reused medium and fresh medium with similar lipid productivity, but in some cases, like nutrient, nitrogen and phosphorus, reused medium even showed higher removal efficiencies. Same thing. So, the final one, reuse. Reutilizing spent medium showed high potential in reduction of material cost for microbial lipid production process. So this is one way to cut down the cost compared to existing technologies we use to generate even third generation biodiesel. I think that's it. Thank you.
Thank you very much, Mr. Shim. Is there any question in the room? Yep.
Thank you. It's only a question related with the wastewater treatment. Which kind of wastewater treatment is normally used for irrigation in this kind of crops?
But domestic wastewater, household wastewater, we usually use so-called activated sludge process. It's biological process. But for food industry wastewater, it depends. It depends where you are. So in case of China, this kind of brewery wastewater, they usually use what we call primary treatment. Primary treatment is mainly based on sedimentation. And then they discharge, and then in sewer, in combined sewer mixed with domestic wastewater, and then goes to wastewater treatment plant, and then treated. So it's like, we also tested separately, actually, say, food industry wastewater and domestic wastewater. But this is closer, using mixed wastewater, this is closer to what we have in practice, actually worldwide. Because pretty much everywhere, especially all the regions, I think Barcelona included, all the regions, we all have combined sewers. We don't have separate sewer to separate city wastewater from rainwater, storm water, right? Or even industrial wastewater.